In this video, we're going to be talking about reflections. Reflections are one type of transformation that can happen to points on a coordinate plane. We're going to talk about several different types of transformations, but those are going to be different videos. In this video, we're just dealing with reflections. If you think about a mirror being a reflection, if you stand in front of a mirror, if you stand 2 feet away from that mirror, your reflection is going to look as if it's 2 feet behind the mirror. If you stand 6 feet in front of a mirror, then the reflection is going to appear as if it's 6 feet behind the mirror. So reflections are always equidistant from each other. If you remember what that word means. Equidistant means same distance. We're going to have two different types of reflections. One where we pretend that the y-axis is the mirror, so reflections across the y-axis. And in a couple minutes we're going to talk about examples where the x-axis is the mirror and we reflect things across that. But first let's deal with the y-axis. If I have a point A at -4, 0, let's plot it just to see what it looks like. That's A. So it's about 4 units away from the y-axis, or 4 units away from our mirror. So if you remember what I just said, the reflection is going to be the same distance on the other side of the mirror. So it's going to be 4 units away over here. And we label our points normal, but reflected points are the point with an apostrophe. So the reflected A point is going to be A apostrophe. You can also call it A prime. So let's see, this x value was at 4, right? Positive 4, 0. Let's compare these two coordinate points here. The x values are opposites, and that's what happens when we reflect across the y-axis. So x values when we reflect across the y-axis, x values are opposites. And y values are the same. So two little rules to help you. Since we're reflecting across the y-axis, well, the y values should stay the same, and the x values are now going to be opposites, and this was A prime. Okay, let's do another example here. Trying to remember these rules, we're going to apply them. Let's try A at -3, 2, and B now. Let's try B at -6, -4. Let's see what happens when we reflect segments now. So -3, 2 is right here, that's A, and -6, -4 is right here, that's B. Alright, now we're going to talk about the reflections. So the opposite x value for A would be +3. A prime is the reflected, so opposite x value is +3. The y value stays the same, so it's 2. So 3, 2 is right here, and that's A prime. B prime, or B reflected, is going to be the opposite of -6, so +6, and y value stays the same, so it's still -4. So find 6, -4, it's right there, and that's B prime. So now if you want to go ahead and connect your points, you can look at their segments and see that they are in fact reflections of each other, if the y-axis was your mirror. Alright, let's keep going talking about reflections. Try this example here. If A is 4, -3, and B is 0, 4. Let's see what they look like. 4, -3 is right here, that's A. B is 0 and 4 on the Y, so that's B. So here's kind of a special case where one of the points is on the axis that we're trying to reflect over. Well, it should just stay right where it's at. Let's figure it out here. So mathematically, A prime is going to be the opposite x value, so instead of +4, -4, y value stays the same. So -4, -3 is right here. That's A prime or A reflected. B reflected, well, the opposite of 0 is just 0. So it's going to stay right there, and the y value stays the same. So it's going to be the same exact point. So this point is both B and B reflected. And if you remember that the y-axis was our mirror, so yeah, that makes sense. There we go, they're reflected. Let's do another special case here. A at 3, 4, and let's say B is at -2, -3. So +3, +4 is right here. That's A. -2, -3, that's B. And as you can see, our segment is already crossing the y-axis. So what's going to happen if we reflect it? Well, let's use our rules. So A reflected is going to have the opposite x value. So instead of +3, it's now -3. Y value stays the same. -3, 4 is right here, and that's A prime or A reflected. B reflected is going to have the opposite x value. So +2, same y value, -3. So +2, -3 is right here. That's B reflected. And as you can see, doesn't matter if our original segment or points cross over the y-axis, we can still reflect them. Alright, we can also draw points that create shapes. And let's see what happens when we do that. It's a little easier to visualize the more points we put on. Let's put, oops, we don't want that color yet. We want A to be 6, 2. Let's put B at 6, 6. And C now is going to be at 2, 2. Alright, so A is at +6, +2. B is at +6, +6. Let's label these guys as we go. And 2, 2 is right here. That's C. So you don't have to connect the dots, but eventually we will be talking about area of a shape, so we might as well get that shape that we're creating there. Alright. And let's reflect it. So A reflected is going to have the opposite x value, so -6. 2 is going to stay the same. B reflected is going to have the opposite x value, so -6. Y value is the same. And C reflected is going to be the opposite x and the y the same. So let's find -6, 2. That's A prime or A reflected. -6, 6. B prime. And -2, 2. That's C prime. And if we connect them, we'll be able to see that we got ourselves a reflected triangle. There we go. Let's talk about a couple other things that hopefully make sense using this picture here. Think about the area of this triangle. You don't have to figure it out, but just think about the size of it and look at the size of the reflected triangle. Excuse me. Are these two areas any different? Hopefully you said no, they are not different. Reflecting points or reflecting shapes does not change the area of those shapes. What about angles though? Look at this angle BCA, angle BCA. Well, BCA over here is right here. Are these angle measurements any different? Well, they shouldn't be. So reflections do not change angle measurements either. And if you think about segment length, so the length of BC here did not change. It's still the same length when it gets reflected. So lengths of segments, lengths of lines, lengths of rays, Anything that has a length or a size does not change when it's reflected. We are going to talk about transformations where the size does change, but not for reflections. But what it does change, here's the most important thing. If you think about line BC here, or segment BC, I guess is more accurate. What about the slope of that segment? It seems to be up 4 over 4, which is 1, right? 4 divided by 4 is 1. But what's the slope of B reflected, a segment of BC reflected? That slope is going down 4 over 4. So it's negative 4 over 4, which gives us negative 1. So as you can see, the slopes of reflected images are opposites. Slopes are opposites in reflections. Alright, let's get into the x-axis now. Reflections across the x-axis. So we're talking about the x-axis now. Well, it's just going to be the opposite of what we just did. So x values now, since we're reflecting across the x-axis, x values are the same. And now the y values are going to be the opposites. So let's do an example here. Let's do 0, negative 4, and we'll call that A. So 0, negative 4 is right here. And if we reflect it, the x value now stays the same, so it's still 0, but the y value is now opposite. So the opposite of negative 4 is positive 4. 0, positive 4 is right there. And that's, oops, there we go, right there. So you can see those points reflected. We didn't label that guy. There we go. Now it's good. Alright, so try and remember these rules now. Just the opposite of what we were just doing. Let's do a couple more examples. I think we can just hop right into the shape. Let's use the exact same one. Let's see if we can do it here. So it's 6, 2, that was A. B was at 6, 6, and C was at 2, 2. Let's put those on the graph. 6, 2 is A. 6, 6 is B, and 2, 2 is C. And we can connect them if you want to get the shape. Alright, so let's reflect this across the x-axis now. So the x values are all going to be the same. All going to be the same. 6, 6, and 2. The only thing that's going to change now are the y values. The y values are going to now be opposite. So instead of positive 2, we get negative 2. Instead of positive 6, we get negative 6. And instead of positive 2, we get negative 2. Let's plot it and see if it looks reflected. 6, negative 2. And that was our A prime. 6, negative 6. That was B. And 2, negative 2 was C prime. Connect them and see how the reflected image looks. Excuse me. There we go. So that's reflections, two different kinds. Remember that if you reflect across the y values stay the same, but the x values are opposites. When you reflect across the x-axis, the x values are the same, y values are opposites. But you can always just visually do it on a graph, and then hopefully with enough practice you can just remember the rules. What else? Remember that areas stay the same when we reflect. Lengths stay the same. Sizes stay the same. But the one thing that is a difference is the slope when we reflect it. So slopes of lines and segments are opposites when we reflect. Alright, see you in the next video.